Assalamu alaikum wa rahmatullahi wa barakatuh. We are going to continue solving paper 1, topic 4, and topic 9 for high-level oscillation and waves. Question 38 from the document. Here we have a sound wave has a wavelength. So lambda is 0.2 meter. What is the phase difference, delta phi, between 2 points along the wave, which are 0.85 meter apart? So the distance between them, delta D, is 0.85. So the formula, the phase difference divided by 2 pi equals distance divided by the wavelength lambda. Cross multiplication, so delta phi will equal 2 pi times delta T, delta D, delta T is 0.85 divided by lambda, lambda is 0.2, and you should get 1,530 degrees. Here from among the option, we don't have 1,530 degrees. So how we're going to find an angle between 0 and 360 that corresponds to this angle. Okay. So we're going to find an angle between 0 and 360 correspond to 1,560. So we have 1,000 1,530 divided by the total angle of a circle, which is 360. This will equal 4.25. So 360 fits into 1,530 4 times. Now this one, 0.25. Okay, this will be reduced. This will be my reduced angle measure. Okay, so this, the part that left over, will be my reduced angle measure. Now, how many degrees are taken care of in the first 4 cycles? So I have 4 times 360. I should get 1,440. So I have 1,440 degrees that are taken care of in the first 4 cycles. Now, how much is left over after these 4 cycles are reduced? So my original angle is 1,530 minus 1,440, this one, we should get 90 degrees. So the answer is 90 degrees. C is the correct answer. Now next I'm going to solve question 45. Again, I'm not skipping these questions because they're not important. All of them are important, but they're easy to solve. If you have any question among these questions that I left, just ask me during the class time or send me an email, or you can send me a message on ManageBack. Now we'll go to question number 45. The refractive index for light traveling from medium X to medium Y is 4/3. So N from medium X to medium Y. Now remember, the refractive index, it's a it's a relative refractive index. Relative means a fraction. This is the first medium. This will be the second medium, 4/3. So this one means the refractive index for medium X over the refractive index for medium Y. And the refractive index for right traveling for medium Y to medium Z, so N from Y till Z equals 3/5. Again, from N, that means NY over NZ, NY over NZ. Now the question is, what is the refractive index from medium X to medium Z? So NX to Z, NX to Z. So this will be NX over NY, this one, times that one, NY over NZ. NY and NY, they cancel out. So I will have NX, the refractive index of medium X, divided by the refractive index of medium Y. Okay? Now NX over NY, NX over NY, substitute here. NX over NY, it's 4/3 times 3/5. This and this, the cancel should give me 4/5. So the correct answer is 4/5. Okay. Now here, 46, you have a pipe of fixed length closed at one end. What is the third harmonic of the pipe divided by the first harmonic of the pipe? Now, if N equals N times F1, the first harmonic. Third harmonic, N equals 3, so it will be 3 times F1 divided by F1. This one and this one, they cancel out. So the correct answer is C, 3. 47, you have the graph shows the variation with position S of the displacement. The displacement X. So here we have a displacement versus position of a wave undergoing simple harmonic motion. What is the magnitude of velocity? Now remember, velocity is derivative of the displacement. Derivative of the displacement or the slope. Okay, so to find the slope at point X, here it's a horizontal, the velocity is 0. This one here, the curve is moving up, so V will be positive and it's maximum. It's a steep slope, so it's maximum value. The value is maximum. Here it's moving down. It's moving down. The velocity is negative, but still steep slope, so it's also maximum. So at which point the magnitude of the velocity? So at X, velocity 0. At X, velocity 0, not maximum, 0. At Y is maximum. Maximum, you see, I have here. Here at Z is maximum, it's not 0. So the correct answer is B. We eliminate answer A and C because at X is not maximum, it's 0. So we have two options, either B or D. We eliminate B, D because at Z I don't have maximum velocity. Okay, now we're going to question 49. We have a particle that undergoes simple harmonic motion. The graph shows the variation with velocity of the particle versus time. What is the variation with time of the acceleration of the particle. Now, what is the acceleration? Acceleration is the derivative of the velocity or change in velocity with respect to change in time. The slope, in other words, is the slope. So at this point, the slope is 0, so the acceleration is 0. If I take a point here, the acceleration is greater than 0. It's positive. Okay, so I'm going to look at a starting point that starts with from 0. I have this one start from 0, and I have this one. This one doesn't start from 0, and this one doesn't start from 0. So I'm going to eliminate C and B. Next, I'm going to look for A greater than 0. That means the slope is moving up. The particle, the motion of the particle is moving up. Now this particle is moving up. This one here is moving down, so it's not correct. I'm going to eliminate D. So the correct answer is A. Now next, I'm going to solve question 52. Okay, question 52. We have two pulses are traveling towards, not this one, sorry. We have unpolarized light of intensity I naught. Unpolarized, it means it's vibration, electric, and magnetic field. Okay, light it's electromagnetic wave. So the electric and magnetic field, they vibrate in many directions. And we said for simplicity, we'll take only two directions, vertical and horizontal. So this is unpolarized, I naught. First, it's incident on the first two polarizer sheets. So this is the first polarizer sheet, okay, and second polarizer sheet. When it passes through the polarizer sheet, polarizer will allow only half of the wave to pass through. So it will allow only either the vertical or the horizontal. Now the horizontal will pass through. So the intensity here will be I naught divided by 2. Half of the intensity will pass through. Now, which sheet must be rotated and by what angle, so that the light intensity, I should have the light intensity I naught over 4. Okay, so I have to rotate one of the sheet. I'm going to rotate sheet 2. I need to calculate this angle, how much. So the formula I'm going to use, I naught I will equal I naught cosine square the angle. Okay, so this is I1. Now I need to find I2. I need to find what is I2. So I2 will be the previous intensity I1. I1, it's I naught divided by 2. Cosine square, I'm going to take 45 degrees. Cosine 45 is square root of 2 over 2. Square it, I naught over 2. When you square root of 2 is 2 over 4. This one, when you square it, square root of 2 over 2 square will give me 2 over 4. 2 over 4, it means half. So this will give me I naught over 4. So the angle theta will be cosine inverse square root of 2 over 2. 45 means cosine inverse 42 over 2. So what will be the correct answer? Will be C. I'm going to rotate either one of them, 1 or 2, either one of them, and the angle is cosine inverse square root of 2 over 2. Okay. Okay. Let's check this one. You have 53, you have when a sound wave travels from a region of hot air to a region of cold air. From hot to cold. Hot, the molecules are further away from each other. So the index of refraction here will be for hot air will be less than the index of refraction for cold air. Okay? So what will happen when it goes light or sound goes from low index of refraction to high index of refraction, it will bend toward a normal. The velocity here will be less. Lambda as well will be less. The distance, lambda is the distance between two crests or two trough, or the distance between 2 points that are in phase, or they have the same, they're doing the same thing, same oscillation. So this is lambda. Why? Because the air molecules, they cross to each other. So the wavelength will be packed close also to each other. So I will have less lambda. So lambda will be decreased when the frequency, the energy frequency will not change. So frequency will remain unchanged while the wavelength will what? Decrease. 54, in simple harmonic oscillation, which two quantity always have opposite direction? Simple harmonic motion, acceleration always directly proportional with the displacement in the opposite direction. So it's acceleration and displacement. So you see the question, these questions are easy. That's why I skip them. Okay. But it doesn't mean they're not in the exam. You would expect everything in the exam when you study for the IB external exam. Now 55, you have a girl in a stationary boat observes that 10 wave crests pass the boat every minute. So I need the period. The period, it's time divided by the number of cycle or the number of oscillation. Now what's the time? 1 minute. Time 1 minute. In 10 wave crests, so it will be 1/10. 1/10. The correct answer is A. Okay. Now the other question I'm going to solve is question okay, question 56. 56. Now to solve this question, let me explain similar one to it so you will understand this one. Here you have a wave like this is displacement, okay, this is distance x, traveling distance, and I have a wave like that. It's here and then there. Okay, suppose this is point A, this is here B, this is point C, this is point D, and this is point E. Okay, now at point B, this is the quarter lambda. Quarter lambda, it means the phase is pi/2. At this point, the phase is pi, it's half lambda. This one is 3 pi/2, it's 270, and this one at point E is 2 pi. Okay. Now, at point C, before point C, the particles are moving forward and have, so before point C, the particle have a forward displacement forward displacement. Before this point, the particle have forward displacement. And after point C, the particle have backward displacement. Forward and backward. Before and after. That means this point is under compression. Compression. Now, if we go to the question, same thing. If we look at the point 1, before and after, forward and backward. So which one is at the center of compression will be 1. 0, I have a refraction here. It's not correct. And number 4 also is not correct. 58. Okay, 58. The frequency of the first harmonic standing wave in a pipe that is open at both ends is 200. What is the frequency? So open at both ends, it has the same equation as the pipe that is closed at both ends. So Fn will be velocity divided by 2L and here N. While what is the frequency of the first harmonic in the pipe of the same length that is open at one end? Open at one end, the frequency V over 4L. See the relation between them. This I'm going to call this one F closed. And this one I'm going to call it F open. Okay, so F closed, it's half F open. Half. If you multiply half here, you should get 4. So F closed, we have times 200. So the answer is 100 hertz. 100 hertz. C. C. 59. Okay. 59. 59, we have a traveling wave. Period is 5 milliseconds. So this is T. Here. Travels along a stretched string of speed. You have the speed 40 meters per second. 2 points on the string are 0.05 meter apart. What is the phase difference? So the same equation. Delta phi divided by 2 pi equals delta D distance divided by lambda. Okay, I need delta pi. It will be 2 pi times delta D, which is 0.05 divided by lambda. Lambda, I have to find lambda. Okay, so lambda, we need to find it from this equation. D equals lambda over time period. So lambda, do cross multiplication, will be the velocity. Velocity is 40 times the time times 5 milliseconds. 5 times 10 to the power -3. And you should get 0.2 meter. 0.2. If you calculate this one, you should get half, pi over half. Pi over half. Okay. I'm going to solve question on thin film interference, which is question 65. I'm going to question 65. Now, before 65, let's solve 62 first. Then we'll go to 65. 62. 62, you have a diagram shows an interference pattern observed on a screen in a double slit experiment with monochromatic light of wavelength 600 nanometer. The screen is 1 meter from the slits, 1 meter from the slits. So this is the capital distance D. What is the separation of the slits? So I need the small distance D. I need the small distance D. Now, distance between two constructive interference S, okay? Two constructive interference. I have a total distance 1 centimeter divided by how many bright fringes? Let's count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 1 centimeter, 1 times 10 to the power negative 2 meter divided by 10 fringes, 10 bright fringes. So this distance S is 0.001. So now we can use the formula lambda over D equals S divided by capital D. Lambda is 600 nanometers times 10 to the power negative 9 divided by going to swap, okay, divided by S is 0.001. This will equal D divided by 1. So we calculate this one. 600 times 10 to the power negative 9 divided by 0.1. You should get 6 times 10 to the power negative 4 meter. 6 times 10 to the power negative 4 meter. Okay. Question 68. 65 is easy. Here I have two. We'll have interference at this surface here and this surface here. Now light goes from air to film. Index of refraction here is high, so I will have the light when it hits. This is the incident light. When it will reflect out of phase. By how much? By lambda over 2 at this point. Now the second point, it goes from film to air. Air is low. The index of refraction is low. So when it goes to high, this is high. It means I will have 1. It will reflect out of phase by half, by lambda over pi. Okay. Here I won't have any phase change. So here we'll have no phase change, So I need constructive interference. To have constructive interference, I should have integer number of lambda. Here we have lambda over 2. So if I had another lambda over 2, I should get integer lambda of lambda. So the equation I'm going to use, the light travel double the distance if this distance is d. So double the distance times n will equal m plus half lambda. M plus half lambda. Take m equals 0. So this will equal 2nd will equal lambda over 2. I need d. Okay, so swap. So d equal lambda divided by 4 and here lambda over 2. Lambda over 2. So the correct answer is A. Lambda over 4n. Okay. Okay. 68 is easy. 68, you're going to use the formula. Here we have a diffraction pattern for light passing through a single slit. Single slit, if the angle is really small, so I'm going to use theta, here, sine theta equals lambda divided by the width of the slit B. Okay, here you have a relationship between the intensity and the diffraction angle. What is the wavelength of light divided by width? Lambda divided by B, it will give you the angle theta. The angle theta from the diagram is 1 times 10 to the power negative 2. So it's 1 times 10 to the power negative 2. That means it's 0.01 radian. 0.01 radian. Okay. Now last question, 69. 69 will have light is incident on a diffraction grating. This is high level. The wavelength lambda 600 nanometer and 601.1 nanometer. So this is lambda 1 and this is lambda 2 are just resolved on the second order of spectrum. So n equal to just resolved. Just resolved means I can see the two sources of light. I can see them I can distinguish that I have two sources of light. I can distinguish between them. Now, how many slits of diffraction grating are illuminated? I'm going to use the formula that we studied in the class. Wavelength divided by number n, number of orders, times delta lambda. Now, lambda is 600 nanometer divided by n is 2. Delta lambda is 601.5 minus 600. Okay. And if you calculate this one, you should get 200. So the number of slits